All right, welcome to the fourth video of section 7.2. Now, you've seen three different types of functions and how to graph them. Now, in video 3, we looked at how we find the asymptotes and how we graph functions that are in this format, ax plus b over cx plus d. Now, in video 2, we saw how we graph functions in this format, a over x minus h plus k. Now, the nice thing about this format here is that your asymptotes are given to you, h and k. You know exactly what your asymptotes are, and it's very easy to find them. So what we're going to do is we're going to see how we can take a function that's written in this form, convert it over to this, and then we're going to graph it, and then we're going to compare it as a transformation to our parent function, a over x. So first, what we need to do is we need to take our numerator and we want it to be a constant. So what we're going to have to do is actually do the polynomial division of 3x plus 5 divided by x plus 1. So remember back, we want to see how many times our denominator goes into our numerator. So we take 3x plus 5, take our denominator outside, and we're going to go ahead and remember, we want to see what do we have to multiply x by to get 3x. So we get 3. Now we're going to multiply, in this case, we're going to multiply 3 times x plus 1. So we get 3x plus 3. We're going to subtract, and we end up with 2. Now, there's no other values to bring down. So that means this is 3 with a remainder of 2 over our x plus 1. So what we've done is we've just turned this into a mixed number. So this is just 3 plus 2 over x plus 1. Now we can turn this into the format a over x minus h plus k. We just take this 3 and write it on the end. So this ends up being 2 over x plus 1 and then plus 3. So now we've taken 3x plus 5 over x plus 1 and rewritten it in this form, a equals x minus h plus k. Now, in this problem right here, we want to go ahead and graph this. So what we want to do is we first want to take our asymptotes. So in this case, we know that x equals -1 is our vertical asymptote, and y equals 3 is our horizontal asymptote. So in order to graph this, we're going to take our function, and again, at y equals 3 to 3, so we're going to have an asymptote right along here, and at x equals -1. So right here, we're going to have another asymptote. So what we need to do now is to plot this, we need to pick points to the left. So in this area, so -2, -3, -4. And then we need to pick points in this area to graph. So x equals 0, 1, 2, and 3. And we'll get our two functions. Now, if we go ahead and if we look at this, we want to compare this function as a transformation of a over x. So if we go to Desmos, let me get out of this. If we go to Desmos and let's change this to our original function, which was 3x plus 5 over x plus 1, this is what our graph looks like. And what we did is we showed that that was the same as 2 divided by x plus 1 and then plus 3. Notice these are the identical graphs right here. So this shows that our math was correct. Now, if we want to compare this to a over x, which is just 2 divided by x, here's what we get. Now, our original function is 2 over x, and our new function is 2 over x plus 1 plus 3. So let's look at what that looks like as far as transformations go. if we look at transformations, we've taken our graph here and we've shifted it to the left. We've taken our graph and shifted it 1 unit to the left. So now we have our asymptote at x equals -1. So that's a shift 1 unit to the left. And we've also raised our horizontal asymptote up to y equals 3. And this is a shift up 3 units. So we went 1 to the left and 3 units up. So notice, if you look at our function, our translations are just our new asymptotes. So y equals 3, that means we did a vertical shift of 3. X equals -1 means we did a shift to the left 1. So notice, if you look here at your x minus h and then plus k, k is just your vertical transformation and h is your horizontal transformation. And the same rules apply to transformations we've been looking at all along. Again, if it's x plus 1, that means it's a shift 1 unit to the left. If you're adding 3 to your entire function, it means that it is a vertical transformation, vertical translation. Okay, very straightforward on here. The key is translating these into the new format. So you make sure you do your long division and you see how many times your denominator goes into your numerator, and then you write the remainder over the denominator. So what I want you guys to do as a practice is I want you to go ahead and rewrite g. So we've got 2x plus 5 over x plus 2. I want you to rewrite that in the form a over x minus h plus k, and then tell me what the transformation was as you compare it to a over x. So tell me, how did it translate? All right, so answer these all in the same box. So you're going to have your new function in this form, and then you're going to describe the transformations from the parent function a over x.